Good evening, students. Are you able to hear me? Yes or no? Okay. So what was the last topic we were discussing? So we discussed about closed and open organ pipe. Sorry, we discussed about this thing, right? Transverse wave on a stretched string. Then we discussed how does the vibration occur for air column in open organ pipe. Right. So is there any doubt that you have from the topics that we have discussed till now? So you would have understood one thing by now that in the case of transverse waves and in the case of open organ pipe, we have this first harmonic, second harmonic or first overtone, third harmonic or second overtone, and so on. Right. Same is the case in the same is with the case of open organ pipe as well. So they both have the similar fact, except the fact that velocity in the case of open organ pipe will be root of gamma p by rho, and the velocity in the case of transverse waves will be root of t by mu. Okay. Now, the last but one concept that is there is vibration of air column in closed organ pipe. So closed organ pipe means it is not closed at both the ends, it is closed at one of the ends. So it is closed here. Let's say the length of the organ pipe is capital L, okay, and you create a vibration here. When the vibration is created, we can have half standing wave, or we can have 1.5 standing waves, or you will have 2.5 standing waves. Whereas in the other two cases, what happened? In the case of transverse wave, you either had you had a complete standing wave, one complete standing wave, or two complete standing waves, or three complete standing waves. Right? The same is the case with the open organ pipe as well. Whereas in this case, what will happen? It is not possible for you to have a complete standing wave, and the logic is very simple because we know that always at the closed end there is a node, and always at the open end there is an antinode. Okay, the same is going to be the case with respect to 1.5 or 2.5 standing waves. Clear? So if I take the length of the organ pipe as L, if half standing wave is to be formed, then what is going to be the length of it in terms of wavelength? Tell me. L is equal to L is equal to what is L is equal to, guys? So observe, no, when it is half standing wave, it is the distance between a node and an antinode. So what will be the value of L? Guys, the last warning, if you're not going to speak, I'll just cut this call and leave. Okay. You want me to do that? I'll do it immediately. I can't waste my energy. I'm not yet completely recovered. I hope you understand that I'm coughing continuously. Speak.
Sir, is it lambda by 4?
Yes. It is lambda by 4. So lambda is equal to 4 into L. Then what is the value of lambda? I've been discussing since yesterday. Lambda is equal to V divided by F. So this is 4L. F is equal to V divided by 4L. Okay. So this I will call it as fundamental frequency. Fn is equal to V divided by 4L. Similarly, when one and a half octave, one and a half standing waves are formed, then what is going to be the length? So in this case, what is going to be the length? L will be equal to the distance between a node and a node is lambda by 2, and the distance between a node and an antinode is lambda by 4. So lambda by 2 plus lambda by 4 is going to give us 3 lambda by 4. So lambda is equal to how much? 4L divided by 3, and lambda is V by F, which is equal to 4L by 3. F is equal to 3V divided by 4L. So what has happened here is, if you observe, after 1, it is V by 4L. How much is the value you are getting for the second scenario? It is 3 into V by 4L. Are you able to understand? Whereas in the case of transverse wave in a string or in an open organ pipe, what is that you got? You got V by 2L, then you got 2V by 2L, then you got 3V by 2L. It kept on going like this. Whereas in this case, what is happening? After V by 4L, the next value that you are getting is 3V divided by 4L. Is that clear? So there is nothing like 2V divided by 4L. After this, for this part, for C part, if you do, what is that you're going to get? Can you tell me?
5e by 4l.
Correct. So you'll get 5e by 4l because lambda by 2 plus lambda by 2 plus lambda by 4. So it will be 5e divided by 4l. Okay, that is 5e divided by 4l. Did you understand? So frequency in this case will be 5e by 4l. So what should I write this as? This I will write it as F3. This I will write it as F5. So F1 is V by 4l, which is called as the fundamental frequency or first harmonic. Okay. Similarly, in the second case, you will have 3V divided by 4L, which is called as the third harmonic. There is no second harmonic. It's called as third harmonic or first overtone. Whereas in the other cases, what did we have? We had second harmonic and first overtone. Now, in this case, we are having third harmonic and first overtone. And here, what is going to happen? You will have fifth harmonic. So this number in the numerator will decide the harmonic number. So it is fifth harmonic and second overtone. Like this, if it keeps on going, right, when the closed organ pipe with the mth overtone is there, then what is going to happen? Then what is going to be the frequency of it? So frequency will be equal to 2m plus 1 into v divided by 4l. So mth overtone will have this frequency. How did we get that? 2m plus 1. See, for second, it is 2 into 2 plus 1, 5. For first overtone, it is 3. So how did we get that 3? 2n plus 1. So 2 into 1 plus 1. So first overtone plus 1. So it is going to give you 3. You're able to understand? Similarly, for the mth overtone, it is going to be 2m plus 1 into v divided by 4l. So if you take the ratio of the frequency of overtones in this case, it will be 1:3:5. So this can be a 1-mark question also. Okay. Is there any doubt?
No, sir.
Okay, good. And the last concept that is left out in this chapter is beats. Listen. So, 2 classes before, I told you one important thing. When you have two waves of same frequency moving with the same speed in the same direction in a medium and they superpose on each other, that gives rise to a concept called as interference of waves, right? Similarly, you have two waves of same frequency moving with the same speed in opposite directions, right? When they're moving in opposite directions in a medium, superpose on each other, then they produce what? They produce something called as stationary waves. And that stationary wave is what we saw for for a string, a closed organ pipe, and an open organ pipe. Similarly, when you have two waves of slightly different frequencies moving with the same speed in the same direction in a medium superposed on each other, that gives rise to the concept of beats. So what is important for beats? The two waves are supposed to have slightly different frequencies. Okay. So that's where the concept comes. So when you have two sound waves of nearly same frequency, which are produced simultaneously, then the intensity of the resultant sound wave increases and decreases with time. Okay. So the change in intensity of sound is what is called as the phenomenon of beats. And the time interval between two successive beats is called as beat period. And the number of beats per second is what is called as beat frequency. Let me explain this. Suppose this concept of beats is applicable only for sound. It is not applicable for any other wave. Okay. Suppose, you know what is a tuning fork, right? You would have seen it. I'm assuming you would have seen it. So you have one tuning fork and you have another tuning fork. Let's say one tuning fork is of frequency 6 hertz and the other is of frequency 8 hertz. If you observe, they both have slight frequency difference. So that is their natural frequency, right? So when you hit it, right, when you create a sound, what will happen is this will start producing a wave. And when you hit this, this will also start producing a wave. Okay. Now what will happen is, if this wave and this wave are written mathematically and they if they get combined with each other, that is, if they superpose with respect to each other, then you will get something like this. Then you will get some output of this format, and this is what is called as beats. So you're able to see two waves here, one with a continuous line and one with dotted lines. So those two waves are having slightly different frequency. When they get, and they're moving in the same direction, when they superpose on each other, the resultant displacement will be something like this. So what is the important point you're able to observe in the case of resultant displacement? Here, are you able to observe that there is a change in
reduced?
Sorry?
Is frequency reduced?
It's not frequency, it is the amplitude. So amplitude means displacement from the center to this point is there. No. If you see, the amplitude is changing with respect to time. So here, if you see, you take whichever wave you want, okay, whichever wave and whichever pulse you want. At any instant, if you try to measure the amplitude, right, if you try to measure the amplitude, it is the same for any pulse. Whereas in this case, what is happening? See, if I try to measure the amplitude here, if I try to measure the amplitude here, if I try to measure the amplitude here, it keeps changing as a function of time. Are you able to understand? And this concept of increase and decrease in the intensity means amplitude. Okay. So remember this concept. Intensity is directly proportional to amplitude square. So more is the amplitude of the wave, more will be the intensity. Intensity means loudness. You will be able to hear that sound louder. Okay. So intensity is directly proportional to amplitude square. Is the concept clear, guys? So that's why it is written as variation in amplitude. Is it clear, everyone?
Yes, sir.
Okay. Now our job is to understand how to find this beat frequency. So, excuse me. Now, we will try to read the statement again. When two sound waves of nearly same frequency are produced simultaneously, then the intensity of the resultant sound wave increases and decreases with time. So what is the meaning of this? Intensity means the amplitude of the resultant sound wave increases and decreases with time. This change in intensity of sound wave is what is called as the phenomenon of beats. And you're able to see two successive beats, right? So if you're able to measure the time between two successive beats, then that is what is called as beat period. Okay. If you take the reciprocal of the beat period, that is what is called as, if you take the reciprocal of the beat period, that is what is called as beat frequency. Are you able to understand?
Sir, which is 1B?
From this part to this part. You're able to see this dotted line, right? So from the dotted lines crest to the other crest.
Yeah, okay, fine.
Now we are going to get into the analytical details of beats. So analytical details means till now we understood what we try to understand what is this concept. Now we will try to derive the expressions for it. Okay. So I can write down the heading as analytical treatment of beats. Okay. So let's consider two waves of frequency F1 and F2, which are propagating simultaneously in the same direction. Okay. So now what we are doing is, for simplicity, we'll assume that the amplitudes of the wave at x is equal to 0 is 0. Sorry. For simplicity, we'll assume that the amplitude of these two waves at x is equal to 0 are equal. So it is this, something like this. So you're able to see the dotted lines and the continuous lines both have the same amplitude at the starting point, right? Then we can write the equation of the first wave as y1 is equal to a sine of omega 1t, and y2 is equal to a sine of omega 2t. Okay. Then resultant is y1 plus y2 according to the principle of superposition. So if I take that a outside, a becomes a into sine of omega 1t plus sine of omega 2t. So a into sine a plus sine b formula. 2 sine of, yeah, tell me.
Sine
Omega 1, omega plus 1 plus omega 2 by 2 into t into cos of omega 1 minus omega 2 by 2 into t. Okay. Now what we will do is, we'll take this 2 and we'll combine it with this cos and combine with the amplitude. So 2a cos of omega 1 minus omega 2 by 2 into t into sine of omega 1 plus omega 2 by 2 into t. Okay. If I take something like this, then this is the resultant displacement of the beat that is getting produced. Okay, this is the resultant displacement of beat. And this part is the resultant amplitude of beat. So when this is the resultant amplitude of beat, I can write it like this. 2a cos of omega 1, I can write it as 2 pi f1. Omega 2, I'll write it as 2 pi f2. The whole divided by 2 into t. Is it clear till this step? Is it clear till this step?
Sir, why are we writing? How are we writing it? Omega.
Omega is 2 pi f.
Yeah, okay, okay.
Okay. Now you remember for standing wave also, we got something like this in the case of amplitude. You guys remember that? So in the case of there I told you, when you put amplitude is equal to 0, you will get a node. And you put amplitude is equal to maximum, you get an antinode. In a similar way, here what we will get is for this part, that is when the amplitude is maximum. So we need to find the times at which this amplitude is maximum. Time at which, see, there is an important derivation, guys. Write it along with me and get the doubts clarified. For finding time at which amplitude is maximum, I will put cos of pi into f1 minus f2 into t is equal to plus or minus 1. So why did I put plus or minus 1? Because amplitude can be either plus 1 or minus 1. Then pi into f1 minus f2 into t should be equal to how much? When will cos give you plus 1? When will cos give you plus 1?
0.
Is it only 0?
N pi.
0, 2 pi, 4 pi, 6 pi. For plus 1. When will cos give you minus 1? So minus 1 will come at pi. Guys, you learned trigonometric equations or not? You know how to write the general solution? Yes or no? Yes or no? Adhikaga answer பண்ணுங்க. If not, I will teach you. Adhikaga I'm asking. If you know that cos theta is equal to 0, theta is equal to 2n plus 1 into pi by 2, you know this or not? There is a general solution. You have this, in trigonometry, second term.
Yes, sir.
Similarly, cos theta is equal to cos alpha means what is the value of theta? Something like 2n pi plus something will come, no? Plus or minus. What is it? Okay. I myself will write it. You guys figure it out how it has come. So the answer is n pi here. So n pi is not coming for plus 1 or minus 1 separately. It is a combined effect of it. So pi and pi will get cancelled. P will be equal to n divided by f1 minus f2. So this is the time at which the, the amplitude will be maximum. So n belongs to integer set. Right? When I put t is equal to 0, sorry, n is equal to 0, then t will be 0. N is equal to 1. T will be 1 by f1 minus f2. N is equal to 2. T will be 2 by f1 minus f2. You're able to understand? So 2 divided by f1 minus f2. It keeps on going like this. Now, if I take the time difference between these two, what will you get? T1, if I call this as T2. So T2 minus T1 is equal to 1 divided by f1 minus f2. And this is what is called as beat period. So if I take the reciprocal of beat period, what will I get? I'll get f1 minus f2, and this is what is called as beat frequency. And this is what is called as beat frequency. Clear? Similarly, for minimum amplitude, this thing is there, no? Cos pi into f1 minus f2 into t should be equal to 0. Then pi into f1 minus f2 into t will be equal to, at least for this, tell me the answer. If cos theta is equal to 0, what is the value of theta?
1 pi by 2.
And
Odd multiples of pi by 2. 2n plus 1 into pi by 2. So pi and pi will get cancelled. T will be equal to 2n plus 1 divided by 2 into f1 minus f2. Now, if you put n is equal to 0, you will get T is equal to 1 divided by 2 into f1 minus f2. Similarly, you put n is equal to 1, you will get T is equal to 3 divided by 2 into f1 minus f2. It keeps on going like this. If you put n is equal to 5, what will you get? T will be equal to 11 by 2 into f1 minus f2. So this I'll call it as T1, T2, something like this. Then T2 minus T1 in this case will be how much? It will be 2 divided by 2 into f1 minus f2, because the denominator is the same. 3 minus 1 is 2. So 2 and 2 will get cancelled. It will come out as 1 by f1 minus f2. And this is what is the beat period. Are you able to understand? So this is the beat period. And if you take the reciprocal of it, you will get f1 minus f2. And this is the beat frequency. So you asked me, right, what are those 2 points? Now you should have understood. If you try to measure between two maximum points, two successive maximum points, or between two successive minimum points like this period is what is called as beat period, and this will be how much? 1 divided by f1 minus f2. So this is the formula you're supposed to remember.
Yes, sir.
So the last part is doing some problems. With that, we are done with this chapter. Okay. Let's try out some problems. For a certain organ pipe, 3 successive resonance frequencies are observed to be 425, 595, and 765 hertz. So resonance means basically something which is created forcefully. Taking the speed for sound in the air to be 340 meters per second, explain whether the pipe is closed at one end or open at both the ends. Determine the fundamental frequency and length of the pipe. So the frequencies that they've got are 425, 595, and 765. So what you will do is you will take the ratio of it. So when you take the ratio of it, what will you get? So this will go 85 times. This will go 119, huh? 119 times, and this will go 126 is 5, 153 times. All right. So I think everything should be divisible by 17. 17 fives is 85, 17 sevens, last 49. So 17 sevens is 49. 4, yes, 1. So this should work. So 5 is to 7 is to 9. So 5 is to 7 is to 9 are the frequencies. Okay. They are the 3 successive frequencies, and the successive frequencies are in the ratio of odd numbers. So odd numbers means what should happen? It should be a closed organ pipe, right? Had you got them as successive numbers 1, 2, 3 or 2, 3, 4, something like that, then it would have been an open organ pipe. So determine the fundamental frequency and length of the pipe. So how will you find the fundamental frequency? So 1 minute. You know the frequency of the fifth harmonic. Fifth harmonic is 5 times the fundamental frequency is 425. So how much will you get? 85. Yeah? So the fundamental frequency is 85 hertz. And they're asking you the length of the pipe. So fundamental frequency is equal to V divided by 4L. So from here you can find the length. And generally the speed of the sound is also given. So 340 divided by 4L is 85. So find the value of L from here. It comes out to be 10. Is this problem clear? So is this problem clear or not,
Yes, sir.
guys? Yeah. Next one. So let's do a simple problem first that is based on beats. So there are two tuning forks, A and B, which are sounded together, gives 6 beat per second. So 6 beat per second is what? It is the beat frequency. Correct? Together they use. So together means it is a resultant. So resultant will generate beat frequency. With an air resonance tube closed at one end, the two forks give resonance when their two air columns are 24 centimeter and 25 centimeter respectively. Calculate the frequency of the tuning forks. With an air resonance tube closed at one end, means it's an organ pipe which is closed at one end. There are two forks which give resonance when the two air columns are 24 and 25 centimeters. So if I take the first frequency, okay, so if I calculate the frequency of the tuning fork A, that comes out to be how much? It is V divided by 4L. Right. So F1 will be equal to V is how much? Did they give it? Calculate the frequency of the forks. Okay. So F1 is equal to V is not known. So V divided by 4 into L is 24. So V divided by 96. Similarly, F2 is how much? V divided by 4 into 25. So it will be V divided by 100. And we know the fact that F1 minus F2 is equal to 6. So you have two unknowns and two equations. Just calculate them. So find F1 in terms of F2. So F1 by F2 is how much? 100 by 96. So F1 will be equal to 100 by 96 into F2. Substitute it here, calculate F2. Once you find F2, substitute it back in F1 minus F2 is 6. You will get the value of F1. Clear?
Yes, sir.
So that's it with respect to this chapter. Okay. Doppler effect is not there. So remaining problems you can try from the textbook itself. Okay. So I've covered everything that is possible. Let me check if I missed something. That's it, guys. So we are done with this chapter. So it's now your turn to revise it. You can use the study material and revise it. And as I mentioned, kinetic theory of gases, I'll upload all the videos by tomorrow and you can go through them. And reach out to me if you have any doubt in the student support number. Okay. Is that clear to everyone?
Yes,
Is
sir.
it clear? Yes. So any other doubts, any other concept you want me to explain? Is there any other doubts that you have? Any questions in your mind? You tried to study something but couldn't understand.
So could you explain the kinetic theory of gases?
Kinetic theory of gases, see, like it's a vast chapter. Now I can't complete it even if I start. So it's better, like 2 chapters mixed together will not make sense. That is why I'm not doing it. 1 minute, wait. You want me to teach? It's not a problem.
Sir,
But I can't complete it. I can't complete it. That's what I'm trying to say. Okay.
So then, have you, like, I'm not sure whether have you uploaded the kinetic theory video
Or not?
No, it is there. I can upload it tomorrow is what I'm trying to say. They
Okay,
are
sir.
there. I can upload it tomorrow.
Sir, can you give any questions related in kinetic theory, which is exam point of view?
Yeah, I'll give that. I'll give all those things. That's not a big deal. But the question is, I'll give you sample question papers also for this test that is coming. Only thing is, you guys should work. I'm able to see that most of you are not working. Okay, I'm ready to give. So I'll give you sample question papers that is needed for the test and all. Okay. So the reason why I'm not starting it now is because this chapter is actually a heavy chapter. Okay. This is the first time. Last year I took it for 8 classes. This time this is the first time I'm completing from 3 classes. Okay, because of the exam constraint. I never thought the exam will come this fast. Okay, so you take some time to revise this chapter, concentrate more on oscillations. I've seen, still now I'm able to see that most of you have not completed oscillations chapter except few. So I already have the list in my hand. So you guys work more on oscillations and waves today. And tomorrow you can work on kinetic theory of gases. I'll give you the printed notes also. Okay, I'll give you the soft copy of the notes immediately after. I'll try to send it by tonight. Okay, I'll give those notes, I'll give those videos, just correlate them and study. That is more than sufficient. And I'll tell you what all points you need to study. That's enough. Okay, will that work?
Yes, sir.
Yeah. So that's it. Yeah. So you revise this. Everybody has the study material, right, for this chapter. I think for kinetic theory of gases also, you can refer to the study materials for some important points. So one advantage in study material is you have these things. The concept map is there, no, that will help you. For a quick revision, you have all the formulas that are written here. So that you need try to write down all the formulae and memorize them to solve the problems faster. Okay, at the same time, not only the formula, you should also know how to derive them. That is more important. Here, guys. So that's all for
Yes, sir.
today. Okay, so you can revise, make use of the time to revise it. Okay, start preparing for your exams.
Thank you, sir.
Yeah.
Thank you, sir.